Reddy from Narayana Technos. So today's our topic is reading the array elements from the keyboard and printing the array elements on monitor using subscript and as well as pointers mechanism. So where we have the first one is reading the array element from the keyboard. First one is using subscript. Subscript is nothing but static mechanism. So in static mechanism, there will be the number of rows and columns or fixed rows and fixed columns. So let us, for example, if you are having the declaration of array like this, int a of 2 of 3 I comma j. What is the meaning of this declaration is create integer type of memory with two rows. In each row, it's creating the memory for three columns. So once it is created a memory for two rows and as well as three columns, then we are entering the elements like this. Printf enter the array elements. For I equivalent to 0, I less than 2 rows, I plus plus. And each row, there are three columns. So for j equivalent to 0, j less than 3 columns, j plus plus here. Then scanf %ld address of ij when I0 and j0, when I is 0 and j is 0. So scanf function is reading one integer value and stored in address of 0 0. Next time j plus plus is nothing but 1, is reading another element stored in address of 0 1. Next time j plus plus 2 reading another element stored in address of 0 2. Next time j plus plus 3 condition false, then I plus plus 1 less than 2, again j will be 0. Scanf read another integer value stored in address of 1 0. Then again j plus plus read another value stored in address of 1 1. Then again j plus plus 2 less than 3, again read another integer value stored in address of 0 2. Then j plus plus 3 less than 3 condition false, I plus plus 2 less than 2 condition false come out from j and as well as I loop. So like this it will store our array elements in address of 0 0 10, address of 0 1 20, address of 0 2 30, 1 0, address of 1 0, address of 1 1, address of 1 2. So our elements has been inserted into this memory like this. This is using the subscript mechanism, nothing but static mechanism, where the number of rows and columns are fixed, that is in a program itself only. Second one, in the previous mechanism, if users required various number of rows and various number of columns here, nothing but various number of users are required various rows and various columns. Maybe some users may be required less than 3 columns or more than 3 columns, or less than 2 rows or more than 2 rows. Then it's a wasting of memory or else is a overflowing the memory. To overcome this problem, we have alternate mechanism, it's dynamic mechanism, that is implementing using pointers mechanism. So if you are implementing using pointers mechanism, we should create a dynamic memory programmatically. So to creation of dynamic memory programmatically, what is our requirement is pointer to pointer variable rows and columns. So here we declare into pointer to pointer a r comma c comma I comma j. First we are accepting the number of rows and columns. Scanf %ld accepting rows and columns. Then once we accept the rows and columns, then we are allocating dynamic memory like this. A equivalent to into pointer to pointer malloc r into 2. R is nothing but number of rows and 2 is nothing but in each row it is required 2 byte of memory, because the rows here it's a pointer variables. Any pointer variable required 2 byte of memory here. So that we already explained in the previous videos. So what is the meaning of this typecasting mechanism? After allocation of dynamic memory, that is stored in a pointer to pointer variable name is a. So here it is just going to creating like this. How it is going to creating it? So in base address, that is malloc function is creating 4 byte of memory in 1000 byte. That is 1000 and 1002. These 2 bytes, nothing but these 2 memories is going to creating 4 byte. This 4 byte is dividing into 2 integer pointers. That is a of 0 and a of 1. That is 0th location and 1 location. That address is stored in a here. So after creation of dynamic memory for rows here, then we are creating the dynamic memory for columns. So in how many rows we require to create this memory for columns? R number of rows. So that's why we are putting a loop for I equivalent to 0, I less than or I plus plus. And a of I equivalent to into pointer malloc c into size of integer. Here it may be the columns may be integer type, float type or character type, but row is always pointer variable, but columns are different here. Say right now c is 2 and row is 2, nothing but 2 columns here. 2 into 2 nothing but 4 byte. 4 byte memory is creating, that is stored in a of 0. Next time again 4 byte creating and stored in a of 1. So it's nothing but it's just going to creating like this. How it is going to creating here? So first it is going to creating the memory in 2000 byte. in 2000 bytes going to creating 4-byte memory. This 4-byte memory is to integer value memory. That address is stored into a of 0, that is 2000 is stored in a of 0. Then again I plus plus is going to creating the memory immediate to this memory, nothing but in sequential array always will be going to allocating the memory dynamically in sequential. In 2004 again it's going to creating 4-byte memory, that is integer type of memory. That address is stored in which memory location? A of 1 here, that is A of 1 is 2004 here, A of 0 is 2000 and A of 1 is 2004. So it's going to creating like this here. After creating this memory here, then we are asking to user here printf into the array elements. For I equivalent 0, I less than R number of rows, I plus plus, j equivalent 0, j less than C number of columns, I plus plus. Then scanf %ld a of I plus j. So we already explained in the previous video how to access the address of array elements, that is using column base, row base and base address base mechanism. So then otherwise we can also say the pointer a plus I plus j here. First time when I0 and j0, scanf function is accepting one value and stored in a of I plus j. What is I value? 0 plus j, 0. So a of I, what is a of I? First time a of 0. What is a of 0 here? 2000. 2000 plus 0. What is 2000 plus 0? 2000. So value is inserting at 2000. Next time j plus plus. What is j plus plus? 1. Scanf function again accepting another value. So insert that value in a of I, nothing but 0 plus 1. A of 0 plus 1. What is a of 0 here? 2000. 2000 plus 1. What is 2000 plus 1? 2002. The pointer always, a of 0 is here pointer. Pointer always increments to one location. What is that location? Is 2002. Insert the value at 2002. Next time again j plus I plus plus. So then j is 0. Scanf percentage a of 1 plus 0. What is a of 1 here? 2004. 2004 plus 0. Next time j plus plus, nothing but 1. So scanf function accepting another value a of 1 plus 1. What is a of 1? 2004. 2004 plus 1. What is 1? 2006. Insert the value at 2006 here. So like this it will read the array element and print stored into the this address of array memory locations here. Now the second one is printing the array element, where we have the first one is using subscript mechanism. So in previous example we given that how to read the array elements mechanism using the subscript mechanism, that is 2 rows of 3 columns. We just accepted like this, a of 0 and a of 1, 3 columns like this here. After we stored these elements, now we are going to printing. How will we print these elements here? That is a of 0 is 1 row and a of 1 is 1 row. Here we have 3 columns, a of 0 0, a of 0 1, a of 0 2, a of 1 0, a of 1 1, a of 1 2. These are the column names, nothing but subscript mechanism. So how we are printing these elements here? For I equivalent to 0, I less than 2 rows, I plus plus, j equivalent 0, j less than 3 plus plus and j plus plus c. Printf %d slash t a of ij. Nothing but when I0 at j0, stored in a of 0 0. Next time j plus plus a of 0 1. Next time j plus plus a of 0 2. Next time a of 1 0, a of 1 1, a of 1 2. Like this, these values will be stored like this, printing the elements on monitor. So second one is using pointers. Using pointers are nothing but dynamic mechanism. In dynamic mechanism already we given that R number of rows and C number of columns elements we have been already accepted and stored into the address of our array memory locations that we are printing. How we are printing here? For I equivalent 0, I less than or I plus plus. Then for j equivalent 0, j less than c, j plus plus. Printf % slash t, pointer a of I plus j. We given already a of I. A of I is plus j is nothing but address here. Pointer a of I plus j is nothing but pointer a of I. What is I first time? 0 plus 0. A of 0 0. What is a of 0? 2000. 2000 plus 0, 2000. Pointer. Pointer gives value from this 2000. What is value of 2010? It gives 10. That is printing on monitor here. So after printing, then next time a plus plus. That is nothing but pointer a of I plus j. Pointer a of 0 plus 1. What is a of 0? 2000. 2000 plus 1. What is 2000 plus 1? 2002. Pointer. Pointer gives 2002. Value of 2002. What is value of 2002? 20. Similarly, next time j plus plus 2. Condition false. I plus plus. Then j is 0. Again pointer a of 1 plus 0. What is a of 1 plus 0? A of 1. What is a of 1? 2004. 2004 plus 0 is 2004. Value 2004. Pointer gives value 2004. Next time again j plus plus. What is j plus plus here? 1. So again pointer a of I plus j. What is I? 1. A of 1 plus j. Nothing but 1. Or else pointer to pointer a plus I plus j. What is pointer? A of 1. What is A of 1 here? 2004 plus 1 is 2006. Pointer gives 40. So similarly, otherwise we can also just like this. Pointer to pointer a plus I plus j. Pointer to pointer. A is nothing but here 1000. A plus I nothing but 0. A plus 0. What is A plus 0? 1000. Pointer gives value at 1000. What is value at 1000? 2000. Plus 0. Nothing but again 2000. Again pointer. Nothing but value at 2000. Nothing but 10 here. So pointer to pointer A plus I plus j. Pointer to pointer A plus 0. Pointer to pointer A plus 0 plus 0. Nothing but pointer to pointer A plus 0. A plus 0 gives 1000. Pointer gives value at 1000, 2000. After that again we are saying that 0 plus 0. Nothing but 2000 plus 0, 2000. Again pointer. Nothing but value at 2000. Nothing but 10 here. Like this you can access these array elements using the location base, row base, or it is a base address of array mechanism. So there are three ways of mechanism to access the address of elements and as well as accessing the array elements mechanism, that is a column base, row base, and as well as base address base mechanism here. So users, if you like this video, please like and share, and for more updated videos please subscribe our channel. Thank you one and all.